All right, so our starting point is going to be basic types. We need to start right here. So let me explain a little bit more about types. So JavaScript, by default, it's not a typed language. On other languages, we do get the ability to add annotations or, to have that type ability. But with JavaScript, we don't get it. We just go, declare some variables, we assign the values, and that's it. JavaScript has no idea what's going on. But whenever we use TypeScript, we get the ability to let the application know what type of value you're going to be using, if it's a string or a number or a function or an object. And that's what we get with one of the things we get with TypeScript. Now, inside TypeScript, we get pretty much two ways. And any kind of a typed language, we get the implicit and the explicit way. We kind of already talked about this. Now, there's a more technical name for this. On the implicit, it's going to be called typed annotation, and on the explicit, it's going to be called type inference. So the implicit or type annotation, that's the real name, is when we get the ability to declare some variables, and we can go to the actual code and let the application know what type we're going to be using, with the colon string or the colon number. I made a mistake right there, but that's okay. So we do get the ability of add types annotations, right? We can go to the code and let the application know what we are doing. The other one is the type inference, and this is when TypeScript is going to go and is going to try to figure out what you're doing. It's going on that auto mode. So for example, we do a let name with the Francis, and we know that this is a string. So TypeScript will assume, since you have a value with a string, it will assume that you have a string. So it's going to go and in memory is going to assign the type of string. So where to use annotations or inference? Where are we going to be using types? Well, we use it on variables, on objects, on booleans, strings, and so on and so on and so on. So we use it pretty much everywhere and all the time. So back in the documentation, the first thing is basic types, and as you can see, you get a reference for different types: booleans, numbers, strings, and depending on what you're using, it's depends what you will need to use. So they're a little bit different. They're pretty similar, but there are some use cases that are pretty weird. For example, like this one, and we're gonna discuss all of this on the next couple sections. So again, this is the first step we need to make to learn TypeScript, and I just guarantee you that after we get the basic types and declarations and the most basic aspects of TypeScript, you will have a better idea of why and how to use TypeScript. So let's go to the next one, and we're going to start with booleans, numbers, strings, null, and undefined. All right, so now we will take care of the most basic types. So you get two different types. You get the primitive types and the object types. So the primitive are like numbers, booleans, strings, null, undefined, and void. Then you get the object types, which are functions, arrays, classes, or objects. They're much more complex, and we will of course discuss them later. So the next couple sections are gonna be a little bit basic and a little bit dumb, but believe me, this is gonna get much more complex very soon. So okay, so what is the first type? Well, we get number types. So I'm gonna put number right here, and I'm just gonna create a variable called, I don't know, cars, and I'm gonna say that this one has a value of 5, which is, we know a number. So remember, we get two different behaviors. We get the inference, which is the automatic type, and the type annotations, which is the manual type. If I hover right here, the inference, it's kind of kicking in. It's saying that we have a variable with a type of number, right? But in this case, what we want to do, we want to learn the type annotations, the more manual thing. So we do it by using the colon and by saying, dude, on this one, I have a number, a type of number. And notice that the color changes, and we get that we type this with not a capital, letter. If I do so, like something like this, it changes completely. It now thinks that we try to use an interface. So again, remember that whenever we use this, we need to add a lowercase, character. So if I change something like here, like a boolean, of course, it knows that we are not using the correct value. We are telling TypeScript that we want to use a number and not a boolean. So we go to the error. Same thing if we we add a value right here at the bottom. I'm going to say cars, and on this one we can do 5 because this one is still a number. And if I hover right here, it's still a number. But if I change it to boolean, it fails. So we get an error. All right, pretty cool. All right, so let me just go back. So now we get numbers. What else do we have? We have strings. All right, so I'm going to go right here at the bottom, and I'm going to say strings. All right, so with strings, pretty much the same thing. I'm going to create a let. Could be const, could be whatever you want. And I'm going to say monkey. And monkey is going to be George. All right, so what is the type of this one? Well, on this one, if it's a string, we're going to do string. All right, pretty simple. Same principle. Then we get the booleans. All right, so boolean. And I'm doing this because this file is going to go to you in a couple minutes. So I'm going to say, I don't know, server. Is this server up? Yeah, I'm going to say true. So if I go right here, we say boolean. All right, again, pretty simple. Now I'm going to do something else, and I will need to do a little bit more explaining. I'm going to say any, and I'm going to create a variable that is going to be called set, and I'm going to do my value, whatever name. You can put whatever you want right here. And this one is going to be 5. Now, if I hover on top of the variable, we know that the TypeScript it's going into the inference mode, and it says that this one is a number. But maybe later I want to have the ability to do my value and assign a boolean or something like that, right? I want to add a true. And of course, TypeScript, since it's doing a number, it's adding the type of number, it's not going to let us change it to a boolean. So you get a different type, which is called any. So if I go right here and say that this one, instead of a number, is going to be any, the error goes away. So this is a special type we get with TypeScript. And whenever we use any, it means that the type for this variable could be whatever we want. Whatever we want. I can do my value and say that this one is equal to an object, and that is okay. I can do my value one more time and say that this one is now equal to an object. And TypeScript will not complain about this because the type it's any could be anything right here. All right, we're gonna expand a little bit more on any in a couple minutes. Then we get the null, just like this, null, and we get the undefined, just like this, undefined. All right, so with this one's pretty much the same principle we are using right here. I'm gonna create a variable called flowers, and this one is gonna be equal to null. And I'm going to create another one called, I don't know, bikers. After a while, I need to get creative with this ones, with the names of the variables. So if I go right here, it knows that we have any. And if we go biker, we get any. So by default, it goes to the any state. And again, it's inference kicking in. But we can go a little bit further than that. And we can say that this one is going to be type of null. And this one is going to be type of undefined, and now undefined. And now TypeScript know that this one is going to be null and this one is going to be undefined. All right, man. So pretty cool. So these ones are the most basic types, right? We need to expand a little bit more about any, and this one is a little bit special. But before we do that, we're going to go and discuss about global objects and arrays. So let's go to the next one and talk about that. So with JavaScript and not TypeScript, just with standard JavaScript, we have available some built-in objects, some functions or global objects. They are called global objects, and you can actually find this on Mozilla. Just the search standard built-in objects, and I'm pretty sure you used this in the past. Let me just give you an example. I'm going to go right here and I'm going to say built-in. Oh, built-in. All right. So for example, I'm going to create a variable called date. And from this one, I want to bring the date. That's one of the features we get with JavaScript. We can pass a new date, just like this. and this one will return the date, right? Pretty simple. I'm going to do console log, and I'm going to print the date. So I'm going to go here. I'm going to go to console, and let me see if I can find. There we go. So I'm going to run the script, and I should be getting the console log of date. So I'm going to press enter, and we get today's date. Pretty cool. Now, what is the type for this one? So if we go to date, we can see that we have some special types that are built in with JavaScript. In this case, since this is a built-in object, we get the type by default. If you want to go more specific, we can say that this one, it's date, and TypeScript will not complain about this. Now you get a lot of built-in objects, as you can see, a lot of this. The most common one is the date, because this is one we use the whole time. Now, then let me show you a different example. I'm going to do math, and what I want to do, I want to bring the math object. Now, later, what I want to do, I want to console log. I'm going to console log, and I'm going to go to that math we are creating at the top, and I want to get the pi. So if I do math pi, and I run the script, I just compile, we're going to get, 3.14, which is pi. All right. So by default, it's going to go TypeScript, and it says that this one, it's type of math. And that's true. So if I do math, nothing is going to happen. If I run the script, everything still works. But what happens if I try to do something like this? I'm going to do pi. We get an error. And again, TypeScript is just a machine. It's not a person. So it cannot guess that you're really trying to, do this. What we are doing right here is we are calling math, and then we are calling pi, which is a built-in method inside math. And pi, which is this method, will return a string. I'm sorry, a number. It returns a number. Since this one, we are using this, and it returns a number, this type, it's not a built-in object anymore. It is a number, because what gets returned at the very end is a number, which is, 3.14. And that's why it's failing, because again, this is a number, not a built-in object. So if I change this for a number, let me do it correctly, a number, it will not complain. Of course, we get the error right here because we are running it twice. If I do just math and I run the compile, we get 3.14, but it's not complaining. So again, you need to be in control of what you're doing if you're not doing type inference. If I do inference, I save this, it's giving me a type of number. It's doing it by default, right? So very cool. Okay, so let's talk about arrays. I'm going to delete this. I'm going to go right here and say arrays. And this is going to take a couple minutes because there are a couple of weird things right here with arrays. First, let me just, go with the most basic part. I'm going to go and create a let with magazines inside. Real simple. And this one is going to be equal to an array. So I'm going to add some values, maybe Vanity Fair. I don't really read magazines, but that's okay. I know that it's New York Post or something like that. Your Post. What else? Wired. All right, I'm just putting names of famous magazines. Okay. So by default, inference is going to kick in, and it's going to say, oh, okay, so you have magazines with a string and then the square brackets. And this is how we would add an annotation for an array. Now, let me give you a different example. I'm going to go right here at the bottom, and I'm going to say let, and I'm going to say, I don't know, booleans, or something like that, booleans, plural. I'm going to say this one is equal, and I'm going to put just an array, just a square bracket with nothing inside. And if I hover, we get pretty much that square bracket, but now it says any. So in the TypeScript world, the types world, whenever you create an array with it will withhold some values inside, you need to specify what types of values are going to be inside that array. Since on this one we are using strings, it's going to be string and then square brackets. And let me just add it right here. I'm going to say string and square brackets, and that's going to pass. And on this one, since there's nothing inside, we get again that any keyword. Again, we're going to talk about the any in a couple minutes. So what I want to do right here, I don't know, I want to add booleans. So I'm going to do true, I'm going to do false, and I'm going to do, I don't know, true again. And it's going to change. We get boolean and then array. All right, so let me add it manually. I'm going to say boolean and then array. All right, what happens with numbers? Same idea. I'm going to do number, whatever, and this one is equal to number and then an array. Let me fix this. And then, you know, same idea. I'm going to do 1, 2, 3, and 4. All right, pretty cool, right? Makes sense. So I'm pretty sure now that right now you're thinking, what happens with, you know, multiple types on an array? Can we do it? Of course we can. I'm going to say let user, and this one is equal to just an array. And we have a string. Then I'm going to add a number, and I'm going to add a boolean. So we get pretty much 3 different types: boolean, string, and number. So if I hover right here, it's giving us the answer. We have a way, of course, to declare this, and it's between parentheses. Pretty simple. So let's manually do this. I'm going to add parentheses, and then at the end, I'm going to say that this one is an array. So we're going to get strings, and then we need to use the pipe right here. It's like the or when you use an if. Well, same idea, but just with 1. So we say string. We're going to get a number, and notice that this passes the parentheses and the number pass. But since we are adding a boolean, we are getting an error. So we need to add boolean. Pretty simple. If I try to push things like, I don't know, let me push Steve, and that one is cool because we are adding the type of string. But if I do user and then push something that it's not string, nor number, nor boolean, we're going to get an error right away. If I do new date, we get an error. So again, this is pretty smart. So let me just delete this. And I'm going to do a console log and console log of this user. And I was testing it like this previously. That's why you get it on the terminal. Sorry for that. Let me just show you. So if I run this, we are getting the Francis, the 23, the true, and the Steve. So with this type of types, this type of annotation, the order does not matter. And notice that at the end we get string again. So, you know, the order doesn't matter. If I change boolean to the first position, let me just go here and do the pipe, we are still good to go, right? The order doesn't matter. Now I'm telling you this because we have a different type of array. When we go to the docs, we get the array and then we get the tuple. So with the tuple, again, it's just pretty much the same idea, but on this one, the order really matters. And then we have a different type of array, which is, you know, multi-dimensional arrays. How can we make it work with the types? So let's go to the next one. I'm gonna give you a brief explanation of tuple and multi-dimensional arrays. Okay, so let me show you how multi-dimensional arrays work. So in few words, it's an array with an array inside. So let me create a variable. This one is going to be, let me delete this. This one is going to be a let of guitars. Let guitars. That sounds good. And this one is going to be equal to an array. So what I want to add is just an array inside, and I'm going to add one more array. So the first values are going to be Ibanez, which is a brand of guitars. Then maybe the number of strings, which is, you know, maybe 6. And then I'm going to say this one is available for purchase. And again, just pretend. And then on the other one, I'm going to give a different name, maybe Fender, something that everyone's know. And on this one, I'm going to say true and then the number of strings. So notice right now on the second position of both arrays, it's something else. On this one, I get a number, and on this one, I get a boolean. And same thing on the other one. So I'm getting different values on the pretty much the same position. So if we need to convert this to a type with a type, what we do, since the order doesn't matter, we need to still do the parentheses, and then we need to add an array, and we pretty much need to do the same thing that here. So I'm just going to copy paste. So we do get a boolean, yes. We get a string, yeah, and we do get a number. Now we are still on error. So this is because we have a multi-dimensional array. We have an array inside of an array. So whenever we have this, what we need to do is just add one more square brackets, and that's it. We are good to go. Pretty good. Okay, so of course, remember that the order doesn't matter. So let me just try to push a value inside of the array. If I do guitars, and then I do a push, and if I try to push maybe, I don't know, a name, like a string, we get an error because I'm trying to push a string inside of this array, the main array, not inside of this ones, right? So we instantly get an error message. If I try to push a new array with just one value of a string, that works. Let me just do the TS decompile. Oh, of course, I need to do console log. Sorry for that. So console log, I'm gonna get console log the guitars. If I run this, everything works. You know, we get a new array at the end. Again, the order does not matter. Okay, so let's talk about the tuple. Let me do one more example on this one, just to be clear. Let's say I want to push a value inside of the first position. So we would do this like, you know, the usual way. First, I'm going to access the first array, then I'm going to push, and then I'm going to push, I don't know, whatever, doesn't matter. So if I console log this, you know, everything is good. We are still on track. So let's go to discuss the tuple. So if we read the documentation, it says the tuple types allow you to express an array with a fixed number of elements whose types are known, but need not be the same. So on the documentation of TypeScript, some things are very cool, some other things are really weird. So the keyword right here, it's fixed number of elements. So let me, again, this is one of the things you will learn by example. So let me delete all of this, and I'm gonna go right here and say tuple. So I'm gonna create a variable that has an array with laptops. You know, laptop, something like that. Very simple. And this one is going to be equal to an array. And at first, we're going to have a Mac, and then maybe a Boolean, maybe false. All right. So by default, you know, we get this way of doing things. We don't get a tuple. We get the strings or Boolean and then the array. So if you want to define a tuple, it's a little bit different. Instead of putting the parentheses right here, we go straight to the brackets, and inside the brackets, we say we want to have a string, and then a comma, and then we want to have a Boolean. Now, notice that we get no errors. What happens if I put string after the Boolean? So, you know, we get an error. Because the application knows that the first value should be a Boolean, and the second value should be a string. So now the order of things inside here really matters. So let me just go back to the good way. Okay, so we get it right there. If I try to add something, maybe enter the first position on the array and try to change it to a number, of course it fails because we don't have numbers right here. Now if I try to change it for maybe a Boolean, maybe true, it does not work because we told TypeScript that the first value should always be a string. So we can only change it for a string, and that is going to work. So you need to keep to bear that in mind. To keep that in mind, that you cannot do whatever you want when you are using a tuple. Now, what's the problem with the tuples? You know, the downside, because this is very useful. So the downside with this is that what happens if you have many things inside here, many values. So you will have to go, okay, so the second one it's number, oh, let me fix it. The second one is number, then I'm gonna have another Boolean, then I'm gonna have another Boolean. So if you have a lot of values right here, this is gonna turn into a problem because you will have a pretty long and confusing string. And this is the downside of I wouldn't say TypeScript, but just types with typed annotations. So there's one other thing you can do that it could be useful. So let's say that you really need to do this. And let me just go back to the previous example. You really need to do this. What you can do, you can create an external file with exported types. So if I do something like type, just something like this, and assign it to something like laptops, and I'm gonna, by convention, a capital, and I'm gonna say that this one it's equal to, I'm gonna do pretty much the same thing, string and Boolean. What we can do we can import the types inside of what we are using. And TypeScript will know that you are referring to this type which withholds a string and a boolean, and this will work. Notice that we are getting no errors. If I run it, no problem at all. Oh, of course, I need to do console log. Sorry for that. So I'm going to do console, and then log, and then laptops. All right. Okay. On the console, and everything is good. We are compiling. So, this is a nice way we get to keep our code not that confusing. So you can create whatever types you wish. Remember that the names are just like variables. You cannot add different types and keep the same position. For example, if I do type of laptops again, and I add one with booleans, it's gonna fail. Again, this one's work just like variables. So we could do something like that right here at the top. I can create a type of guitars with a capital G, guitars, and just export this type to this variable. I can say that this one it's equal to guitars, and that it's gonna pass. It's gonna work. All right, so pretty cool stuff. Now, of course, we're gonna do a lot more about this, and we're gonna discover a lot more new ways of doing things with TypeScript. But for now, this one is the most basic aspect. If you want to check more examples, of course, you can go to the documentation. But I'm pretty sure that this one was, really simple to understand. Okay, so now we're going to talk about objects and functions. So let's go first with objects. Let me add right here, objects. So with objects, it's pretty much the same principle. Now that you know all of this, this is going to be pretty simple. You can even guess how to do it. So the only problem is that they are a little bit annoying. Let me show you why. I'm going to create a variable called map. And this one is equal to an object, right? That's cool. So I'm going to add latitude of 200 and then a longitude of, 300. That's okay. So, of course, to add an annotation, we know that we put the colon, and since this is an object, there we go, that's the annotation. Now, the problem with this is that if we check it right here, this is valid. The problem is that there's nothing really happening right here. We do get an object, and most of the times when we add an annotation for TypeScript, we want to check, and for TypeScript to check, what's inside of the object, not just the object. If I do something like 23, notice that nothing happens, right? It's because there's no checking going on. So if I go back, the way we add this is that inside we say that we have a variable, a property called latitude, and that value, it's going to be a number. Then we do the semicolon, lng, and we say that that's going to be a number as well. And that's going to pass. If I change this for a string, TypeScript, it's kicking in and say, dude, you told us that this was going to be a number and you're adding a string. So this is the way we add an annotation for an object. And I know what you're thinking, this is really crappy, it's a lot of typing, we need to do a lot of typing, and yeah, you will need to do a lot of typing with objects. There's no way around this, because the application cannot guess what you're trying to do. But that's okay, you don't need to do this every time you create an object. You only do it if it's really necessary. But at this point, I cannot teach you a lot more things with this. We're going to learn a lot of more things with everything that we are doing right now when we go to a much more complex scenario. And I'm talking about classes, complex functions, and things like that. But for now, you just need to know that to add an annotation for an object, it's just as good the curly braces and whatever property you have inside. That's it. All right, so let's go with functions. Now, the functions are a little bit different. Let me add the functions. All right. So with functions, it's a little bit different. When we create a variable that it's going to be hosting an array or a boolean or a number, we add an annotation, for example, to tell TypeScript what the value is going to be. In this case, it's going to be a number. In this case, it's going to be a string or a boolean. But that's what the annotation we add. But with functions, it's a little bit different. When we add a variable, just like this, let me just do it. I'm going to call it const and smoke, whatever. And this is going to be a function, our function. So when we add the create variable, TypeScript already knows that this is a function. So what, are we gonna say function or something like this? Well, no. When we add an annotation for functions, the annotation is gonna be describing what the function is gonna do at the end, and what are the arguments. That's the annotations we add. And when I say what the function is gonna do, well, with a function you could return another function, you could return a string, you can do nothing, or maybe trigger a different function. So you could do a lot of things. So that's the annotation, what the function is going to do at the end and what are the arguments. So let me just show you. If I hover on top of this, we get the inference is kicking in, and we get smoke equals to function, fat arrow, and then it says void. So if you remember, when we add a variable that has no initialization, like let me do smokes, and we don't add a value, of course this works, but if we go on top of this, we get any, because this could be of value any, could be string, could be a number, could be whatever. So with functions, we get the void. It's a little bit different. It's kind of the opposite of any, because it says that with any, we might get anything, any type right there on that variable. But with functions, when we say void, is that the function at the end, it's not going to do anything. Or we don't want to, for TypeScript, to start checking what the function is going to do. So let me just add the annotation. It's going to be a little bit weird and confusing, but that's the way it is. I'm going to go at the annotation, the column, and I say that this is a function, is a fat arrow function, and at the end, we don't want to check anything. All right. Don't worry, if you don't get the void, you're going to get it in a couple minutes. We're going to do a lot of things with this. So the only thing that this function is going to do is going to return a function. It's going to trigger a console log with a word function. So again, we are just triggering something on the console. We are not running another function. We are not returning a value, and we are not doing anything like that. So TypeScript, since we are not doing all of that, it's not going to check anything because we put void. So if I run smoke and I run this, we are going to get the console log. Now, if I do a return, let me just do a return of maybe some string, and I'm going to comment the console log, and I'm going to put this one on a console log so we can see if something is going on. If I run this, we can see that we get something, right? So this is a little bit different. Notice that right now I'm returning something. And if I trigger a function right here, it's going to do it. But TypeScript, it's not checking anything because we put void. Now, if we do want for TypeScript to check what this function will return or what's going to do at the end, we get different types. And that's what we're going to discuss right now. So what if you want to add the any keyword? If I do any, that passes. We get no errors. And there's a difference between void and any. When we say any, it means that we want to return what the function returns. It's pretty much anything. It could be a string, a number, an array, a boolean, whatever. When we say void, it means that we don't care what we are returning. We are just running some code, and I want you to check what's going on right here. And there is a difference. If you go to the documentation, it says that the void is the absence of a type, right? We are kind of disabling this. All right, so what happens if I do want to check with TypeScript what the function is going to do? Let's say I'm going to return a string, right? Just like what we are doing right here. So if I put a string right here, that's going to pass because this function is returning a string. What happens if I return a number instead? We get an error. So we are saying, dude, this you told us this was gonna return a number, type of number, and you're returning a string. I'm sorry, a number. So it's the opposite. So that's how we use it for functions. I know that there was a lot of build-up, but this is how we do it. And now let me show you something else. Sometimes when you create a function, and I'm talking in real life, the most common mistake is that function at the end returns nothing, or maybe it's not doing anything. And that is an error because maybe that function needs to return a number, or it needs to return undefined, or it needs to return something. So in this case, if I go back to the string, that passes. But if I comment this out, TypeScript knows that you're not returning anything on the function, so it gives an error because you are expecting a return of a string. So again, TypeScript, it's kind of a very smart about this. And this could be anything you want. This could be a string, a boolean, could be a number, whatever you wish. It's pretty much the same types we've been using right here at the top. But whenever you put that at the top, it means that you expect for this function to return whatever type you're putting right here. All right, so right now we are just checking that the function returns a string. And this is the only thing we do on this spot. We just ask TypeScript to check what comes out. So if I do return something again, we are good to go. Now what happens if we want to check what's happening with the arguments? What comes in to the function, not what comes out. So I'm gonna change this for number. If we do that, of course we get an error because we are returning a string. And I'm gonna say that we want to return a number. And I'm gonna delete this. So I'm gonna say that this function it's expecting two different arguments. So I'm gonna say, okay, so we're gonna be passing an x and a y. As soon as we do so, we can get an error message because if we add the arguments right here, we need to add it on the type as well. And notice again, we are getting warnings. I'm gonna talk about this. So as soon as we do so, we are telling TypeScript that we are running a function that will return a number and we are expecting two arguments. And this function, it's calling this, but it's not passing any arguments. So first, we get an error message just because we are not passing arguments. That's the first thing. If I put the arguments, everything is good to go. Now, the second thing is that, of course, we get a warning. We are passing some values. We are telling TypeScript that we are expecting two different arguments. But since the parameter, we don't have anything right here, TypeScript will not know what type of value we're going to be passing as an argument. So by default, this x parameter has a type of any, could be anything. This could be anything. Could be a string, could be a number, could be a boolean. So TypeScript will not check what type of values you're really passing. And notice that at the top that it says parameter. Whenever it says parameter on TypeScript, it means argument. That's the word they are using for arguments. So, okay, so we are still letting the application know that we are returning a number, but we are not doing any checking on the arguments. The way we do so is by, adding a type. So if we are expecting a number, I'm going to say that we expect a number on the x and we expect a number on the y. And notice that now we get no errors and we get no warnings. If I change this for a string, then we get an error because the application is expecting a number. Same thing on the other one. If I still pass a number, but on this one, I say that I'm expecting a boolean, I get an error on this one because we are passing a number and not a boolean. So again, TypeScript, it's pretty smart with this. And of course, I'm going to change it back. And right now I'm returning 1 plus 1. So we are, I'm returning 1. So it's, an actual number. But what I want to do, I want to return the sum of this. So if you do an expression like x plus y, TypeScript knows that you are getting numbers and that the outcome of x plus y, which is the expression, should be a number. So that's what you're going to be returning at the end, right? It's pretty cool. If I change this for maybe a string, even though we are doing the expression, at the end we return a string. So, we get an error because we are not returning a number. We are returning a string. So again, TypeScript, it's pretty smart with this. Pretty cool. You can check what comes out, and now you can check what comes in. So before we go to the next section to expand a little bit more about functions, I just got to tell you, because if you go to the documentation and check functions or basic types inside functions, you're going to get different examples. So with functions, we pretty much have two sides. The side of the variable, and then we have the side of the function. And it's a little bit weird. Let me just show you. Right now, we are adding this annotation to this side of the varvel, right? We get the varvel, we get the annotation right here, and then it comes the equal and the actual function. So you could do something like this and everything is going to work. Or let me just copy and comment this out. I'm going to paste it right here at the bottom. And we could do pretty much the same thing, the same exact thing, but from the function side. So I'm going to go here and smoke, and you don't need to do it. Let me just do it first because it's going to get a little bit confusing. So we could add the equal, then add this, and at the end of this, add the column to add the type of what we're going to be returning. And let me delete this. There we go. And notice that this is still works. If I run it, everything still works. So we are adding the annotation on the side of the actual function, right? We're adding the annotation directly on the arguments and directly on the function. It's a little bit different than the other one. Now, there's other ways to do this. This is the side of the function. This is the side of the varvel. What we could do, we could add it at all of this nonsense on the side of the varvel as well. And notice that this gets pretty big, but we are getting no errors. If I run this, everything still works, and TypeScript, it's not complaining. And this is called a full annotation. You're adding the annotation on the side of the varvel and on the side of the function. This is full annotations. Now, in real life, you don't need to do full annotations every time. You just can add it on the side of the varvel or on the side of the function, and everything is going to work, and TypeScript will not complain. So, again, in real life, no one does this. No one put the complete annotations because it's just a lot of typing and it's just nonsense. All right. So let's move forward, and we're going to go to the next section and talk a little bit more about functions. Okay, so on this section, I'm going to add just a couple more things. Right now, we've been using a fat arrow function. What happens if you use a named or an anonymous function? What's the syntax? Because, they look a little bit different. If you don't know what a named or anonymous function, let me just show you. I'm going to say function my func, whatever, and I'm going to add the function. So this one, it's a named function. And the anonymous function, it's pretty much when we create a varvel of, I don't know, greed or something like that. And this one is going to be a function, and then we pass a function, just like this. So this one is an anonymous function. All right, just let me add the notes. So because, again, you're going to get this file at the end. So what's the syntax with this? Well, it's pretty much just like this one. And I'm going to do it, of course, on the side of the function because it's the only thing we get right here. So if we are expecting to return a number from this function, let me do the return. I'm going to return x plus y. Of course, it complains because, we don't have any reference to x and y. So I'm going to be expecting a number. At the end, we're going to return a number. And since we are expecting some arguments, I'm going to say the x is going to be a number. And notice that the error on x goes away. And I'm expecting a number right here. And, we get no errors. So this is the way we add an annotation to a named function. So same idea with the anonymous function. So we are expecting, let me just copy the return. There we go. So we are expecting to return a number. All right. And the arguments are going to be x and y, and the annotation is going to be number. And notice that the error goes away. Pretty simple. It's always the same idea. Once you get one, you get, pretty much all. So let me show you something else, and then we're just going to move forward to the next topic, because now at this point, you understand what's going on with functions just a little bit more. So let me just show you with an example. I'm going to create a function called voided. And this one is going to be equal to a function. And at the end, we are not going to return anything. We are not going to do anything. So the only thing I'm going to do, I'm going to, put void. And at the end, I'm going to return null. So I am actually returning something. And this actually happens in real life. Sometimes you can have some functions that they are supposed to do something in between right here. And at the end, maybe you are going to return something, or maybe you're going to return null, or maybe what happens is that you return undefined. So notice I am returning null or undefined, and the type, it's void. So void works when we return nothing, when we do nothing on the function, or we return null on undefined. So TypeScript will not complain about this. Null, undefined, and nothing equals void. If I return a number, I am indeed returning something. So void, it's not good anymore. So we need to put number, and that, it's going to pass. So you need to, you need to remember all of this stuff. What happens, I'm going to give you a different scenario. What happens if your function is going to return, it might return undefined, but maybe you have some other code right here, and maybe it's going to be returning a number, right? So, we are saying undefined, but what happens if we go to that special scenario and we return a number? So what you can do, you can chain the types right here. I'm going to say number. So we might be returning a number, or return nothing, or null, or undefined. So now if I return a number, TypeScript will not complain because it is expecting a number. So yeah, it's all these tiny things that you need to remember. And there's a different scenario. I'm not going to create an example. I'm pretty sure that, but by now you're going to get it. If I go to the documentation and I go to functions, let me just scroll down and find this. You get something that says optional and default parameters. So basically what this is saying is that if you're going to be passing arguments, you need to make sure that you pass the exact amount of arguments. Notice that on this case, it's just creating the function and it's expecting 2 arguments right here. And it runs this with 1 argument, and of course it fails. We get an error because we are passing 1. If we pass 3, it's too many parameters. So if we pass 2, we are expecting 2, and that, happens. That's good. That's good. TypeScript will not complain. So you need to always be sure that you're passing the correct amount of parameters, of arguments. All right, that's it. I just wanted to add this tiny little thing because the previous section went too long. So on the next one, we're going to talk about destructuring, how we can, work with more challenging arguments and everything else. So we are still on the functions topic. So let's go to the next one and talk about destructuring. Okay, so I'm going to give you some use cases for destructuring with the function and some REST operations we're going to do. So don't worry, I'm going to show you example by example. Let me do this, destructuring. All right. So I'm going to just build the function, right? And we're going to take it from there. We're going to just add function variable called TV. So this TV is going to be a function that is going to do something. So at the end, what we're going to do, we're just going to console log a message. So the message is going to be the show, something like that, column, and I'm going to be receiving from this function an argument. It's going to be a channel with a value and then a name with a value. And I'm going to say, okay, so the show, and I'm going to make a reference to the name of the show. And don't worry, it's going to make sense in a minute. And I'm going to say is in, and then I'm going to print the channel, right? Which is the number. All right, pretty simple stuff. Now I'm going to go right here at the bottom. I'm going to say TV, open and close. And I'm going to say, okay, so the channel must be the number. So I'm going to say number 3. And then I'm going to add the name of the show. So I don't know, Monster Wheels, something like that, doesn't matter. So if I run this, we should be getting the show Monster Wheels is in 3, or channel 3 is in. Let me put the keyword channel. All right. So pretty simple. This is just a normal function. What if we have to add TypeScript to this? To add the annotations. Well, first, we are not returning anything. We are just doing a console log. So in this case, we should be at void. All right. So then the other important part are the arguments. Right now, we get a warning because it's attaching the type of any. So it's not doing any checking right here. We could receive anything. So I'm going to say the channel, since it's a number, is going to be the number, and name is going to be the string. All right. If I run this, everything works, and TypeScript, it's not complaining. This is, valid, right? This works. Now, what happens if we had this information on an object, right? How can we do it? So I'm going to go right here at the top. I'm going to say const info, and this one, it's equal to something. I'm going to say channel, and I'm going to say monster wheels. And let me do it correctly, monster wheels. And I'm going to do number, the property number with the, I don't know, the channel number 3. All right, it's just an object. And then at the end, instead of passing the arguments right here, I'm going to be passing the actual object. So now I'm going to go right here, delete this, all of this, and I'm going to say info, because we are getting the object as an argument. And now instead of doing name or channel, we need to make a reference to info.name and then info.channel. Now, again, notice that we are not getting anything from TypeScript. The only thing we are getting is a warning saying that info has a type of any. That's it. Maybe you noticed, maybe you didn't. There is an error right here, but TypeScript, it's not able to check all of this because now we are passing an object, and the object has properties right here. So how can we add an annotation to check what's going on the object? So what we do in this case, we do colon, and then we add the the object, and whatever we have inside the object, we're going to check it. I'm going to say that name is going to be a string, then like this, and I'm going to say that channel is going to be a number. So I'm going to save it, and as soon as I do, it's telling me, dude, you have an error. And actually, we do have an error. Notice I'm saying that the info is the name, and there's no property called name, right? Even though we get it right here, we are saying, dude, you should be getting a name, but on the object, we don't have a name. We have a channel and then a number. So it's instantly just telling me, dude, there's something wrong. And this is a very common mistake that happens. It doesn't matter if you have 10 years developing or programming or 20 years. This is a very common mistake, right? So again, TypeScript helps us to identify these errors when we are just creating the code. We are just coding, and not when we go to the browser and we check it at the end. Pretty cool. So if I wanted to fix this, I'm going to say, okay, so the name is going to be monster wheels. We get the name, and the number is now going to be channel. And the error goes away. And of course, because everything is good. If I run this, we get monster wheels is the channel number 3. So again, it's pretty useful when you work with a lot of code flowing in your application. So what if we wanted to use a little bit of destructuring? I'm gonna copy all this. I'm gonna comment this out, and I'm gonna go right here at the bottom because I'm gonna change it just a little bit. I'm gonna say that, and I'm gonna write all of this again. Let me delete this. I'm gonna say that I want to use a little bit of destructuring on this info. So what I do, if we are just using just JavaScript, no TypeScript, we are not doing any checking right now. I'm going to use the object notation, and I'm going to say I want to grab the name from that info and then the channel, right? So this is going to be passed as name instead of using info because we don't have info anymore. We have name and we have channel, right? And notice I'm not getting anything because we are not doing any checking. If I run this, everything still works. So how can we add an annotation to check what we are destructuring right here? So in this case, what we do the destructuring first, and then we add the annotation to this. Since this is an object, I'm going to say that we want to grab the name, and we want to check that this is a string, and we want to grab the channel from there, channel, and we want to check that this is a number. All right, so pretty much the same thing. We getting the destructuring column, and then we add the annotation so we can check that everything is okay, right? So if I make a mistake, we get an instant error message. So pretty cool. If I do channels, we get an error message. So we always get an error message if you're doing something that is not right. So let me show you a different example. I'm going to go and I'm going to comment the call to TV. So if I run this script, I'm not going to get this console log. I'm going to create a different example. I'm going to say shout, right? This is just a function. We're going to do something, and that something is going to be void because we are going to do a console log. So at this point, you should know what I'm talking about. I'm going to say console log, and this one is just going to console log something that says shout, and we are going to be receiving a 1 argument, a 2 argument, and a 3 argument, right? The names doesn't matter. So I'm gonna print the 1, then I'm gonna do a comma, I'm gonna print the 2, and then I'm gonna print, you guessed it, the 3. So pretty simple stuff. And then of course I'm gonna go to this function, and of course I'm getting an error because I'm not passing the arguments. I'm gonna do so 1, 2, 3, so everything works. And if I run this, we get shout 1, 2, 3. So everything works. Now, what happens if I wanted to use a little bit of a rest right here? I'm gonna do ... and then args, right? And then of course I'm gonna say args because this is what it does. It creates a variable called args, and it will put everything inside of an array. Since now args is an array, the first position is gonna be my argument, my first argument. Let me do 0. This one is gonna be my first because it's an array, of course, and it's gonna be args. So let me fix it, and this one as well. And this one is gonna be 2. Notice we get no errors, and if I run this, of course, this works. So we are using the rest operator from ES6. Now, of course, this works, but we are not doing any type of checking right here. We could receive whatever argument, and we are not doing any checking. So the way we add type annotations to this is pretty much the same idea than here. Just add the column and say then what it's going to happen here. So in this case, I'm expecting a number, arrays of numbers. And then I'm going to use the array notation because this one will convert it to an array, right? So I'm expecting an array with 3 numbers inside. If you get different values, then of course we just go back to the same thing we've learned with arrays. Different ways with arrays of different values is pretty much the same idea. In this case, I'm expecting an array with 3 numbers. Some say, okay, I'm expecting an array with numbers inside. And notice that I get no errors. If I run this, everything still works. If I make a mistake on purpose, I'm going to be passing a string. That doesn't happen because we have a string. If I do something like this, notice that we get no errors, right? This is a little bit different because this one will check that we get an array with numbers inside. Doesn't matter. So in this case, again, we go back to what we talked about arrays previously, that we need to check the tuple, that we are expecting 2 arrays in this case. So you can use the same type on this function right here at the bottom, and of course it will work. So let me add the number 3 right here to fix it, and I want to show you something else. Right now we've been using Destructuring, but on functions. What happens if we need to use it on just a variable? So I'm going to copy all this. I'm going to give you a new example. So this one is going to be info2, and I'm going to change the names for this one. This one is going to be name TV, and I don't know, channel TV or something like that. So a lot of times what we do with ES6, we just declare a variable, and then we destructure from an object. So in this case, it's going to be info2. And what we do, we get, the property into its own variable. So right now, if I do to console log, and then I console log name TV, this one is going to be inside of a variable. So if I run it, we should be getting monster wheels, and we do. So, this is basic destructuring with ES6. Now, of course, we are just creating this, and we can add an annotation here, right? That's the point. So how can we add an annotation to this statement? So I'm going to go right here and add the column. So again, remember that whenever we add the column, it's because we want to add an annotation. So in this case, I'm going to say that name TV, when we create this, we are expecting a string. So if I do string, everything goes smooth because we do have a string. So if I change it to number, that error, but we get an error. And again, this is pretty useful. Right now, we are just doing pretty silly stuff. And we are using this just besides the actual object. In real life, you're going to get a lot of code right here. So this object will not be even near this section. So again, you just need to pretend just a little bit. So in this case, of course, if I put number, we get an error because name TV, it's not a number, it's a string. Same thing with the channel. If I wanted to do it on the same part, I can say channel TV. Of course, we get an error, but that's okay. We're going to fix it right now. Channel TV, and we are expecting a number right here. Let me fix it. Okay. Of course, we are saying right here, but we are not creating anything. So if I put channel TV, that passes. It's correct. If I say that this is a string, we get a whole error message. So pretty cool stuff. So it works really great. Now, again, this is just the tip of the iceberg. What we've been doing all this is just the beginning, man. It's gonna get much. It's gonna get much more complex, but it's really good. You're gonna love it. Okay, so let's go to the next section. I want to talk a little bit more about everything else that is happening here, but that we are not actually doing. What we are doing is to add the annotations manually. But I just want to discuss a little bit more what happens if we go to the other mode in TypeScript. If we go to the invert the mode, the automatic mode. All right, so let's go to the next one and talk about that just a little bit. All right, so I want to give you a couple more tips for the type inference. That right now we're doing, everything with annotations, with the manual annotations, type annotations, which is the explicit way of doing things. We are just providing the rules so TypeScript can know what's happening inside here. Then you have the other way, which is the auto mode of TypeScript. And it works pretty good, but sometimes just will not work. Now, you need to know that when you work with TypeScript, you don't need to annotate every single thing that you do. Sometimes the inference is going to kick in, and the type inference is going to kick in, and it's going to do that job for you. So in that case, there's no need to add an annotation just like this. So we know one case where annotations, the inference fails all the time. Let me just create an example. I'm going to say monitors, and this one is equal to PreSonus. Right, this is an actual brand. So if I go over this, it knows that this is a string. So inference is going to work on this one. Because we are providing a value to this variable, we are initializing the variable. And, it works because it knows. Pretty simple. Now, the way that this will not work is that we initialize the variable. We create a variable. And there's no and we don't initialize the variable right here. So, and it kind of makes sense because JavaScript will read everything from top to bottom. It's going to read, oh, okay, I do get a variable, but I don't know what's going to happen right here. So we're just going to move forward and put any, right? And we're going to talk about any in a second. So since it doesn't know what to do, it will go to the any state. All right, so in this case, inference will not work at all. And you should avoid this every single time. If you know that you're going to be working with strings, so you should put string. All right. So let me show you a different example. I'm going to go right here at the bottom. And let me just create an example. And this is one of the things you learn by example. Just talking, just making everything a little bit more confusing. I'm going to create a variable called discount price, and the value for this one is going to be false. Notice I'm not adding any annotation. I'm going to do price, and the price is going to be 200. All right, pretty simple stuff. Then I'm going to say if, and I'm going to say, okay, so if the price is less than 200, what I want to do, I want to grab that discount price variable and make it equal to 150. And notice that we are going into the error state right away. Okay, and this is because we are saying, we are creating the variable, and we are initializing this with the property, with the false, with the boolean. So the inference kicks in, and it says, oh, okay, so if this dude has a false, I'm going to put type boolean. And that's okay, that's correct. But later in your application, something is going to happen, right? And you're changing the discount price to a number. So since it will not the boolean type that it's putting at the beginning, you're getting an error message. And this is a pretty common scenario. This will happen to you. Sometimes you're going to declare something as with an initial value, which could be false or null or undefined, and then you're going to change it for something else. and the TypeScript is going to detect this as an error. And maybe this is not an error. Maybe the initial varval, the initial value, it's false, and then you want to change it. This is, good JavaScript. It's okay. But, TypeScript will say, dude, this is wrong. So the way to do it is to add a manual annotation, because TypeScript has no idea that then you want to change it. So in this case, it fails. What you can do, you can say, okay, so this is going to be a boolean, but it could also be a number. So in this case, you add an annotation. Again, this is not super good coding, but it's okay. It's okay. If you want to use it this way, it's going to work, but you will need to manually go and give specific instructions to TypeScript. Now, one more thing. This is the only thing I wanted to show you, and I want to give you some heads up with the any keyword. Remember that if we create a varval, whatever, doesn't matter, let's put whatever, and we don't do anything, by default, since TypeScript has no idea what's going on right here, it's going to go and put any. And that is okay, because this varval could be anything. Now, you should always avoid try to use any, and this is, on the documents all over the place. You should always avoid using any. Why? Well, because you're using TypeScript. Whenever you get a type with any, it means that TypeScript will not check what's going on inside this varval. And why are you using TypeScript if you're gonna, not use it? So it just makes no sense. Just don't use TypeScript. So you should always avoid the usage of any, because TypeScript has no idea what's going on. So you're not really using it. Okay, so that's good. Now, again, this is just the beginning. Pretty fun. Now we're gonna go to the next section and talk about interfaces. It's a little bit different. We are just moving away from this basic types scenario. Then we have more logic with types and everything else with classes, for example. But they're a little bit more complex than this, so we're gonna do it in a few sections when we know a little bit more about TypeScript. Now we're gonna go to the next section and we will talk about this, which is interfaces. If you want to check the documentation, that's fine, but don't worry, on the next section, I'm gonna tell you what this is all about. So if we go to the documentation and we try to figure out, and this is what you do in real life when you are trying to learn something new, you go to the documentation. All right, so let's read the first lines on interfaces on the documentation. So it says, one of TypeScript's core principles is that type checking focuses on the shape that values have. So this is something called duct typing or structural subtyping. In TypeScript, interfaces fill the role of naming these types and are a powerful way of defining contracts within your blah, 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 blah. I don't know about you, but this is pretty confusing. And the whole documentation, sometimes, it makes sense. And sometimes they just give, this confusing introductions. Then you check the example and you're going to get it. But at the beginning, it's nonsense. I don't know if they hire the same guy when they create new things, new projects or libraries. It's always the same guy just typing weird introductions. But that's okay. Now, the only thing you need to know about this, the keyword right here, it's contracts. That's it. So in very simple words, interfaces is a way we get to kind of to create a schema, to create an index of types, and we can grab that schema and feed it and use it on different places. We can reuse that schema. If you're coming from Mongoose, or a little bit of Mongoose, you know that you can create a schema on a model, and you use that schema. Well, this is the same idea, but with types. Again, if you don't get it, I'm going to give you an example, and you're going to get it because it's so simple. It's so simple. It's pretty simple. So I'm going to give you just a dumb example again, and remember that interfaces is just a fancy word. It's pretty simple. So there's going to be maybe, let's pretend that you have an application where your user will register, all right? So you will have a function that goes to the database, and it will add that user data to the database, And then at the end, it's going to say something like, welcome Francis or welcome Steve to the website, something like that. Pretty simple. So you will grab the user data from a form, you're going to put it inside of an object, and you're going to feed it to the function that goes to the server. All right. So I'm going to go right here, and I'm going to create just a variable called user data, just like this. And it's going to be just an object, and this object will have the name of the user. I'm going to call it Francis. We'll have the last name of the user. Let me call it Jones. I always use the same dude. Last name, made a mistake right there, last name. And I'm going to go and say that this dude has an age of 25. And then at the end, I'm going to add a greet function. Just a function. The only thing that this function is going to do is going to output a console log. Nothing really important. In this case, I'm just going to return it. And I'm going to say, okay, welcome, just like this, welcome. And then I'm going to make a reference to the name of the user. Since I'm inside an object, I can use this.name, and that's going to work. Again, just pretty simple. Then what I need to do, I need to create a function that will grab the data from this object, and it will go to the server, and then it's going to run this function. All right, so I'm going to do const, and I'm going to say register, and then user. Right now, I'm not using TypeScript. This is just common JavaScript. And this is going to be just a function. It's going to grab the data, this as an argument. We're going to be passing in a few seconds. And first, I need to add user to dv. All right. So I'm going to do a console log. In real life, you're going to go to Axios and make the request and then get the promise. In this case, I'm just going to do a console log. This console log means we've added the user to the database. So I'm going to say add, and I'm going to use the name, maybe data. Let me do it correctly. Data.name, comma, maybe add the last name so we can use most of the properties. Data, and then last name. I'm going to add the age so we can use that property. In real life, of course, you're not going to use everything. But again, we are testing. So to dv. All right. And then at the end, once this is done, this means that we've added the user to the database successfully. I'm going to print a message. All right. And I'm going somewhere. Don't worry. So I'm going to do console log, and I'm going to console log that data in that greet function. All right. So this is going to print welcome and the name of the user. All right. Then, of course, this is not doing anything. What we need to do is we need to go to that function and say that we are going to use this user data right here. So if I run this, we're going to get add Francis, Jones, and 25. So we are getting the values from data, and then we are doing welcome Francis. We are running the function inside that object. Again, pretty cool. This is just JavaScript. There's no TypeScript going on. Even though TypeScript, it's really flowing, it's just doing inference. All right? But there's no manual annotation. Now, notice that right now, it's going to the any state. It's adding the any. So we should avoid this. So what we should do? Well, we should add an annotation. So I'm going to go right here and start with TypeScript right here. I'm going to say that data, it is an object. All right, let me do it correctly. I made a mistake. There we go. Data, it is an object. And at the end, since we are not returning anything, we are going to do void. All right. Now, this data object has some properties. So the first one is going to be name. And name is going to be string. All right. I'm going to do comma. I'm going to say last name, and last name, it's going to be string again. All right. What else? We have age, and age is going to be a number. Right. What else? We have this greet, and notice how I'm going to add the annotation for the function. I'm going to say greet, and I use the parentheses, and then and only then we add the column. And this one is going to be a string. Why am I putting a string? Well, because that function returns a string. If this one returns a console log or does nothing, of course, it's going to be void or maybe something else. Depends on what we are doing. All right. And this is going to work. If I run this, it just works. Now, what is the problem right here? What is the problem? So the problem is that this is a lot of code for some, dumb checking. It's a lot of code. And it gets pretty confusing because everything is on the same spot. Now, right now we are just adding just 4 different properties. What happens if we have 10 or 20? Well, you're going to put right here. It's gonna, it's gonna be a pretty long function. So this is a problem. This could get really challenging. So we get, a feature to make this a little bit easier, and it's called interface. So how can we create an interface? So I'm gonna go right here at the top, and first we use the keyword interface. That's how we create one. Now, if you're creating an interface for to handle user data or something related to user, you should put user. And now notice that the interface, the keyword starts with the capital, right? This is a convention. You need to put it with a capital. And then inside of the interface, it's like with an object notation. What you need to do right here is to add pretty much what we are doing on the actual function. That's it. So I'm going to go and paste it. And we are still saying that we have a name, a last name, an age, and a greet, which is a function. And it does this. That's it. That's the only thing that we need to do. Now, what is the point of creating this interface? Now, instead of using right here, what we're using, I'm going to delete this. And I'm going to say that now we are going to use that interface. So I'm going to put user. And notice that the errors goes away. And if I run this, this works perfectly. So again, this is a way we get to kind of put all the confusing stuff on its own place. And then we just, call it like if this was a varvel or something like that. It's a much easier way, to use TypeScript in this scenario. Another thing where this comes really handy is when you have many functions or many things that uses the same type checking. In this case, we are just using one function, but we could easily do something like this. Let's say that I have another register user function, and it will use the same user interface. So by using this, there's no need for us to, of course, doing all of this right here and then doing pretty much the same right here. So we are just reusing the same set of types. And of course, this is going to work. So let me just go right here and say other. Oops, sorry. Let me go back. There we go. All right, and this is going to work. If I run this, we get it. We get it twice. So very cool, it's pretty useful. And of course, you would use an interface if you need to use it many times, or you have a lot of types on the same spot. That's where interfaces come really handy. Now, if we go to the documentation, we can see again that the keyword was contracts. And this interface, it's not, of course, not just doing type checking. It is a contract that you need to satisfy if you provide this interface. For example, we have this user data, and we are providing a name, a last name, an age, and a function. And the interface says that if we are using right here this function, it's expecting a name, a last name, an age, and a greet. So if you fail to pass one of these properties, you're going to go to error state because you're not satisfying the contract you have between the interface and whatever argument that you're passing from the function. So you will always need to satisfy what you're passing. Remember? All right. So another way to use this, to use interfaces, is that you can put them on different files and you can export them. Because, kind of makes sense. This file, this TS file, the index.ts, might get really big. So if you're putting the interfaces on the same file, it's going to get bigger. So what you can do, you can create a new file. I'm going to call it interfaces. It makes sense. And on this one, you can put the interface right there. Let me put it here. And you can export it just like a varvel because, that's what it is. You can export it, and now you can import it from here. Let's say I'm going to call it user. I'm going to do from and that file, and the error goes away, and we are good to go. So if I fail, let me just make sure this works. If I fail to provide one of the properties that we should be, that the interface is expecting, we go to the error state. Pretty cool. All right, so let me just go back and fix it. So, all right, so let me show you just one more example. because this example that we are doing right now, it's something that we can only reuse on something that it's very related to just the user register. But you can use interfaces to for whatever you wish. Doesn't matter. Let me just delete the other one right here, so to make everything a little bit easier, more human readable. So what I'm going to do, I'm just going to create a function that runs the tooltip. That's it. And the only thing that this tooltip is going to do is just going to show some text. Just going to run a function. That's it. So I'm going to create a variable called tooltip. Doesn't matter. And this tooltip, or it could be not even tooltip, just alert something. Alert message. Something very global. And this one, it's going to be expecting, maybe a message. And then it's going to run a function. So the only thing we're going to do on this one, we're going to console log and, go to message and trigger a function that it's called show. Don't worry, we're going to do it right now. So I'm going to go here. I'm going to go to alert message. And the only thing we need to do is just, trigger that function. So if I go and pass an object, I'm going to say that we have a function called show. And this one, the only thing it's going to do is going to console log and then console log this text or something like this. Oh, no, sorry, not this text. It's going to console log, I don't know, hello guys. That's the only thing we're going to do. We're just triggering the function that we are passing right here. Now, what I want to do, I want to make sure, I want to check with an interface that this function exists, that we are really passing this as an argument. So we could just create an interface. I'm going to go to export, then interface, interface, and make sure that you use a capital. So I'm going to call it, message, something pretty dumb. So message, this could be alert or something like this. So the only thing we are expecting right here is just a show function. And this function, in this case, it returns void because we are just doing a console log. But this one could return a string, a number, or, just whatever. I made a mistake right here. Let me fix it. The thing. But the only thing is that this interface is going to check is that we are providing a function. So, we just import it at the top. We're going to call it message. All right. Message. All right. So now, of course, if we use it, we just put it right here. And of course, we need to change this. I have an autocomplete, kind of an out of format. And sometimes, it's a pain in the butt. But so I'm going to go message, and I'm going to say that the interface is going to check that we are providing a show function. And in this case, it works. So if you fail to provide any of this, it's going to go to the fail state. So, you can use it with whatever you want. Very simple interfaces. So, all right, so wrapping up with interfaces, and it took us just one lecture. It wasn't that hard. It was pretty simple. This one was really confusing. It was, just a very simple thing we can use. So what can we do again? So just summing up, what can we do with interfaces? Well, it's a much more efficient way to sum things, to do a little bit of type checking in a much more controlled way. It gives us clear code. And of course, again, it allows us to detect errors more easily. Now, of course, this is not set in stone. Anyone can go right here and check something on your interface and, break everything. But since you have the ability to put all the interfaces on maybe a couple files or maybe a single file, you can go and check who changed that and why they changed it and find the error in a few seconds. And that's really great. If I have a dollar for every time I have to find someone else's bug on many files, I would buy a house or a car, something like that. So it's one of the main points of TypeScript is to save time, and it saves times by by adding some code. But at the end, in the long run, you're going to save a lot of time just for the debugging and all the errors. So it's a pretty cool stuff. All right. So we are done with interfaces. We're going to use them, of course, much later with a much more real example. But for now, we are going to pass to the next important thing, which is very, very important. And we're going to talk about how TypeScript works with classes.